My name is Annie with ADT Mag, and I'd like to thank you all for joining us. The topic of today's webcast is Spring, Elevating Your Organization to New Heights, sponsored by Tanzu. Before we begin, I'd like to cover a few housekeeping details. Do not hesitate to ask your questions in the console. Deshawn and Dan will be monitoring the Q&A during their presentation and answering all your questions as they come in, and we'll have a Q&A at the end too. Tanzu has provided some resources which correspond with today's event, so please take a moment to check those out as well. And this webcast is being recorded, so keep an eye out for a link in your email to rewatch the presentation. And with that, I'll pass the time over to Dan to get us started.
All right, welcome everyone. Today we're going to be talking about Spring Boot 3 and beyond. We're going to cover a lot of things. My name is Dan Vega, Spring Developer Advocate at Broadcom. With me, as always, Deshawn and I do an office hours show, so I'm used to saying that. But with me, as always, is my good friend Deshawn Carter. Deshawn, how are you doing today?
I'm wonderful. I'm excited. I'm glad that you're here, and I'm just excited to show everybody all the cool stuff that's happening in the Spring ecosystem.
Yeah, that's what we're going to do today. We're going to cover kind of what's new in Spring. We're going to do a little bit of a recap of Spring Boot 3. I'm going to jump into some new and exciting things, at least to me they're exciting, in Spring Boot 3.1, and then some of the really cool stuff that just came in 3.2, which was released just last November. So we're going to do a little bit of a recap. We're going to some things. We'll even show off some code, and then Deshawn's got some demos that are going to be really fun to go through. So I'm going to jump into this. Just a little bit about me. If you want to learn a little bit more about me, you can over at www.danvega.dev. Also, I'm on the Bird app, the Twitter, the X, whatever we're calling it these days, at The Real Dan Vega. Deshawn and I do a show every week called Spring Office Hours. And this was our way of kind of trying to help everyone stay informed with what's new in the Spring ecosystem. The Spring ecosystem is massive. There's lots to catch up on. We're going to do some of that today. But if you have more questions after today, and you're thinking about it, and maybe tomorrow you come up with a new question and you want to talk to us about it, check out springofficehours.io. We do a weekly live podcast where we answer questions, we cover some news, and then we turn that into a podcast. So if you want to listen to us on the go, you can. So we're talking about a new generation of Spring for, needs to be updated, 2024 and beyond. But I want to cover just a few things with Spring Boot 3, just to kind of level set where we've kind of come from when it comes to Spring Boot 3. That is specifically talking about JDK 17 being the baseline, Jakarta EE 9 and 10, ahead of time compilation, observability, and more. Again, I normally spend a lot more time on that, but because Deshawn and I are kind of sharing responsibilities today and doing some other demos, I'm going to fly through that pretty quickly. Then we'll land in Spring Boot 3.1. There was a bunch of really good features for a point release in 3.1, and I want to just kind of highlight one that I'm a big fan of, and that's the Docker Compose module. Then we'll jump into 3.2. Again, 3.2 was released in November. Lots of cool things in there. Probably the big headline we've probably all seen at this point is virtual threads and Project Loom. We'll talk about that. We'll talk about the initial support for Project Crack. I want to focus on the new client abstractions because I think from a developer productivity standpoint, I think these things are really exciting. This is the new REST client, the new JDBC client, so we'll talk about those. So let's just dive into this real quick. Spring Boot 3.0, Java and Jakarta were two of the major themes in this. When we first announced it and said, hey, we're going to baseline on JDK 17, that was a big deal. And people said, wow, if I get an upgrade, I can no longer be on JDK 8, huh? And they thought that was a little bit aggressive. But now as we start to step back and look at the landscape of things going on in the world of the JDK, that's released every 6 months. So, this was announced back before JDK 17 in September of 2021. If we look now, we're on JDK 21. We also have a JDK 22 coming up in just 60 days or something. So it's not far out. So the JDK is rapidly evolving, and we need to be evolving with it. The Spring framework is moving right along with the JDK. So the first thing to note is that JDK 17 is the baseline for Spring Boot 3.0 and above. What does that get us? Well, it's not just all of the language stuff. As developers, we love the language features, right? I want to be able to use text blocks and switch expressions. My favorite is from some of the type system support. Being able to use records really cuts down on some of that verbose those verbose data carrier classes that we're used to writing. And I love using records. I use them wherever I can. The biggest thing, though, is the performance improvements and the security updates you get for free out of the box. So moving to JDK 17 and now 21, I mean, 17 feels like forever ago, right? Now we're talking about JDK 21. So this empowers the framework authors as well as applications. And generally, we want to embrace the latest versions of the JDK. The other big change was Jakarta EE. So this used to be in the namespace of JavaX. So your servlet APIs, your persistence APIs, your validation APIs, those have all moved over to a new package. So if you're moving from something like 2.7 to 3.2, one of the things you have to do is kind of rename those packages. And this is because the Java EE was handed over to the Eclipse Foundation, and one of the kind of raise around some of the licensing stuff was they had to rename the packages, right? So that's a small change. The nice thing is the Jakarta EE9 was simply the package change. Jakarta EE10 is where all of the changes, the evolutions are going to happen. Now these like stagnant APIs that were around forever start to get some changes to them, start to get some updates. That's really exciting to me as a developer. Now, the good thing is you don't have to do this alone. You can use your IDEs. You can use your tools like Open Rewrite and Spring Boot Migrator, and that's really exciting. Another big theme was ahead of time compilation, and the whole reason for doing this is because we want to reduce startup time and our memory footprint when we get to production. And this was a precondition for generating GraalVM native images. AOT is a trade-off. There's an extra build step, but what we get out of it is that reduced startup time and the memory footprint. Now, when we talk about AOT as a theme, one of the big questions that comes up is, why do I want to compile to native? I don't just want to do something because it's a new feature, right? I want to have a reason to compile to native. So there are a few big things. Instant startup, obviously a big one. No warm-up, so you don't have to warm up an execution environment. You're using lower resource usage because there is a less reduced surface attack because we have some closed world dependencies at runtime. We also get this smaller packaging, and at the end of the day, this is reducing infrastructure costs, and that's really important, especially in different types of workloads. So what are those workloads? One of the, I like to start here with like, okay, what are the types of applications that I would want to compile down to native, right? We talked about a scenario where there's low memory and CPU. Maybe where resources aren't abundant. Maybe we don't just have a blank check and we just can't have infinite amount of memory and CPU, right? Where that's a scenario, native images make a really good use case for that. Function as a service. This is a big one. If you're deploying applications into something like AWS Lambda, this makes a lot of sense, right? Because we want to use lower memory. We want that fast startup. Anytime we're scaling to zero, that's a big one. And something I've been doing a lot lately, I know Deshaun and I talk about this often, is writing CLIs in Spring. Now, that if you haven't done that before, that might have struck you a little bit like, wow, what? You're writing CLIs in Spring? Yeah, there's a project out there called Spring Shell. It allows you to write command line applications. And at the end of the day, if I want to run this tool that I wrote for my local machine, the best way to use it is to have it use a less memory and start up really fast, is to compile it down to native. So I'm writing a lot more developer-focused tools for my local machine using Spring and Spring CLI. So some places you might want to assess this are microservices, anywhere using Kubernetes or back office applications. And there are scenarios where, hey, the JVM is likely better. If you're using like high traffic websites, if you have a high throughput, maybe you have a big monolithic application or frequent deployments, then the JVM is likely better. It does really good at optimizing for those different types of workloads. But this is all about providing a solution for different workloads. Finally, the last kind of major theme in Spring Boot 3 was observability. What is observability? It is the ability to observe the internal state of a running system from the outside. And this really consists of logging, metrics, and traces. So we get some direct observability instrumentation with micrometer observation in several parts of the Spring framework. So now the Spring framework is starting to observe all of the things that we're doing, like if we're in a controller or we make a call out to some service using the REST template or the web client or now the REST client in 3.2, we don't have to observe those things. Those things are getting observed already. We can hook into that and find out what's going on in our application. Something else we used to have to do is we'd have to bring in an external dependency if we were dealing with distributed tracing. We no longer need to do that because that is kind of right out of the box. So the biggest thing is when we hear the words logging, metrics, and distributed tracing, what does that even mean, right? So logging can tell us what happened. Sometimes it can tell us why, but really it's telling us kind of what happened and what by emitting events, right? Metrics, though, what is the context of that? So logging could tell us that a particular method took 200 milliseconds. But what is the context of that? 200 milliseconds, is that good or bad? We don't know. It really depends on the context. If we look at the higher, if we jump up higher and look around and say, oh, this method has taken on average 50 milliseconds, and now it's taking 200 to 500 milliseconds, right? The context helps with that in describing what's going on. So now we know that there is an issue. If we didn't have that context, we might go, oh, 200 milliseconds, that's not bad. Nothing's going wrong there, right? So logging and metrics kind of give us some ideas around what's going on in our application. And then a lot of the applications we're building today are distributed, right? So we're making a call to 2 or 3 different systems, aggregating that data, and then doing something with it. And then distributed tracing is going to help us with why that happened, right? One of the biggest things with the Spring Boot 3 and forward, right? So this was a major theme in 3, but this continues to be a story in 3.1 and 3.2, is the observation API. And this might have been the most important change. The idea is you might want to instrument your application, right? So you might want to have to start to add logs. You might want to emit log messages. You might want to add some metrics. So you might want to start and stop timers. You might want to add distributed tracing. So you might have to start and stop spans. And this, if you were to go ahead and do this yourself, you're basically instrumenting your application twice. And there's a lot of boilerplate that goes into this. And thanks to the observation API, we now get a single API that both the framework and us as developers get to take advantage of. And here's a quick example of being able to add some observation into your application. Now, this is a little verbose, but this gives you a little bit more flexibility. You can also kind of clean this up and turn, I didn't have an example of that, but you can also turn this into, an @observed annotation and just have that annotation there to show off, to observe this particular method. So a lot of really great things in Spring Boot 3. Again, I wanted to kind of fly through that because I wanted to get to some other things. But there are a lot of great things in 3 that we just talked about, some of those major themes. The other things that I really like here are the HTTP interface clients, problem details around being able to expose more information in your API errors, some really great dependency upgrades, and more. So that was Spring Boot 3. If you have some questions, if somebody wants to shout them out, that's fine. If not, we will have some time at the end for questions. But that was 3. 3.1 brought some interesting changes, and I want to talk about one of them in the context of something that we probably have all come across before, right? So you head over to GitHub. Somebody directed you there, or maybe inside of your organization, you've been told, here's this project that you need to check out. I'm working on this project. There's some really cool project that I'm going to work on. And I go check it out, and I find out all the dependencies here. Modern applications have a lot of dependencies, and those dependencies have other dependencies, right? And in the case of microservices and distributed applications, there might be other applications that we have to worry about. So I got to check out this really cool project, and it's like Postgres and Kafka and Redis and Elasticsearch and MongoDB. And yes, there are also these 3 other microservices that you need to interface with. This is great, but what if I just want to like start contributing? Now I have to like open up that doc, right? We've all seen that like getting started doc that has 20 pages in it, and I got to install these 15 things just to get up and running. And we know that's not a lot of fun. And even in the open source world, if I see this, I'm probably less inclined to want to contribute to it, right? Like I don't want to do all this to get set up. I want to be able to just like start running with it. So I want to get closer to what we're calling git, clone, run, right? Like I just want to clone a repo. I want to be able to run it. And that gives me that less friction, no more of these long detailed setup documents. I can just start running right away. One of the things that was added in Spring Boot 3.1 was really focused around developer experience. And that had to do with Docker Compose, connection details, and test containers. And I'm really going to focus on Docker Compose, but both the test container support and the Docker Compose support has to do with this connection details interface. So Docker, a really nice way to kind of run a service in a container. How do we do this in Spring Boot 3.1? So if we go create a new application and we say, hey, I want to add Spring Web. I want to add a database, Spring Data JDBC. That database is going to be Postgres SQL. So I add that driver. Now what I do is add the Docker Compose support. And what that does is it sees the services that require a connection. So one of those is a database. So it writes a compose file. If you've used Docker before, there's a Docker Compose file, which you can run Docker Compose up, and it will basically start the services that are required for that application. So it writes out the actual compose file for you based on the other dependencies. It saw that I had a Postgres driver. I'm going to go ahead and create you a Postgres database. Now I don't need to like set that up as a developer. Like it's all there in the project. I can go ahead and run it on my local machine. So if I go ahead and run the application, Spring will see that compose file is there by convention, and it will see the services in there. It will start up that one for me, and now I have a database up and running. Great. What does this mean for me? It means you don't have to remember to run Docker Compose up. I used to have to do this all the time, and I would start my Spring application and realize, oh, darn it, I don't have a database running. I got to go back, run Docker Compose up, then start my Spring app. You don't have to worry about that anymore. If a service is running, it can detect that too, and it will just use them. Also, there's no more, we'll talk about connection details in a second, but this also means that I don't have to put configuration in both my application.properties and my Docker Compose file. It's going to read it from the Compose file and inject it into the runtime for us. And now we only have one place where we have to put that. So that's really handy. The way that this works is, okay, we have this Compose file. Normally, we'd have an application.properties file, right, where we declare a JDBC URL, a username, and a password. So how does that top one get into, like, how does that work? And the way that this works is through the connection details interface. And this was new in 3.1. I love this joke because this is an empty interface, but you see there were 3 authors on here to create a single empty interface. I don't quite understand that, but I'll have a talk with them about it. So we have this empty interface. Now, any interface that implements this, we can start to use some of this connection details in. One of those is the JDBC connection details. And then there's a properties JDBC connection details implementation of that. And so what this does, it knows how to inject that information at runtime. So it takes a look at that compose file, and goes, oh, yes, I know this because I have a way to deal with this. And I will go ahead and take those and construct the properties that I need for a property source to be able to use those at runtime. So no longer do we have to duplicate those in 2 different places. We'll skip the demo for a second, and I'll just jump into 3.2. So that was 3.0, 3.1, 3.2. One of the best ways to kind of figure out what's new in a release is by looking at the release notes. I love the way that the Spring team, when I say lays out the release notes for a release. It says, hey, here's are the things you got to worry about if you're upgrading from a previous version. Here are the new things. Here's some things that have been deprecated. So go ahead and take a look at that. If you do, you'll see that some of the major themes in Spring Boot 3 and beyond has been around runtime efficiency. We already mentioned AOT in 3.2. There's 2 more kind of adding to this runtime efficiency theme, and that is around virtual threads and Project Cracked. Project Cracked is coordinated restore at checkpoint. I'll mention that again in a second. And then around client abstraction. So there's 2 new client abstractions in 3.2. One is the REST client. One is the JDBC client. So we'll see if we can't take a look at those as well. Support for Apache Pulsar, some nice things around SSL bundle reloading, more in observability improvements. We talked about that. That was a major theme in 3. That is going to be a continued story going on. They kind of rewrote the observability story in Spring, and we're seeing that throughout these point releases. So runtime efficiency. I want to jump into Project Loom and virtual threads because this is really a big one, and this is for me one of the most important releases of the JDK in maybe forever. I know JDK was a big release, and ever since we moved to these incremental 6-month releases, there have been some really great features in them. But I don't think I can remember one as big as this. So just to kind of step back, what is a thread in Java? So Java is multi-threaded by default, partially thanks to a class in there called java.lang.thread. And this is really an abstraction over operating system threads. Every thread in Java is essentially a wrapper around an operating system thread. You'll hear these referred to as platform threads. Platform threads are very expensive. They take a lot of memory. They take time to create and destroy. So these have always, not in every single application, you're not going to run into these issues, but when we start talking about concurrency and scalability, this comes up a lot, especially in high throughput systems, right? So Project Loom came along, and it was intended to explore a way to an easy way to use high throughput and lightweight concurrency on the Java platform. If you've been around Java for a long time, I don't remember exact year that this was kind of released, but there was an attempt at this early on called Green Threads that didn't really work out. And now this is back. Project Loom has a couple different JEPs in it, but one of the big ones is virtual threads. So yeah, here you see there are a few different JEPs included in Project Loom. Virtual thread is no longer a preview. It was a preview in JDK 19. The other 2 are still previews even in JDK 21. So that is something to think about if you want to learn more about these. Check out these JEPs. If you can read these online, if you want some interesting, they're very interesting reads into it's not just documentation on it. It is hey, this is the problem. This is the solution. This is all of the things we thought about. These are all the things we didn't want to include in this, and here's why. So I really love reading through these JEPs. So if you get a chance, go ahead and take a look at those. So it was targeted for JDK 21. So it was released in JDK 21, which means there's going to be support. There is support for it in Spring Boot 3.2. They have their own scheduler. You don't want to pull virtual threads. They are lightweight threads that are not attached to your platform threads. So what does that mean? I think it's probably best if we just explain kind of the thread per request model for anyone who doesn't understand. So when it comes to virtual threads, where we have a typical application in a Spring MVC world, right? We create a new Spring application. It's a web app, and it does things that are blocking. What are those blocking things? It means that, hey, if I'm talking to a database or an input stream or another service over HTTP, these things are blocking. And so when I write my application locally, everything seems to work great. But when I start getting a lot of throughput, a really high volume of traffic, things start to crash. We've probably all been there. We start asking ourselves, why is this happening? What can I do to prevent this? And to understand that is to understand what the request model is like behind the scenes. So we get a requested, somebody is asking for something. It goes to something like the web server, in our case, Tomcat, right? That request, when we go ahead and do something that's blocking, like talking to a database, that thread, which we now know is a wrapper around an operating system thread, is being used. It is blocked until that request has been fulfilled. Now, operating system threads are a finite resource. We don't just have an infinite pool of them, right? So we are taking up one of those precious commodities just to make a call to a database or a call to another HTTP service. And there are a maximum number of those. And when those have been reached, each subsequent request will need to wait for a thread to be released to fulfill that request. So that is where, threads come in. We understand Java is made of threads. It's tied to an operating system thread. In the past, we've thought to ourselves, well, okay, we are hitting a wall here. We have some scalability problems. How do we solve for this? There were two primary ways to solve for this before JDK 21 came out. And that was hardware. Hey, we're going to scale vertically by adding more memory or adding more CPU to it. Or we're going to scale horizontally by throwing more servers at the situation, right? So that's hardware. That's one way to solve for it. Not always the cheapest way, right? Another way is asynchronous programming. So we can solve this by writing non-blocking code. We talked about that database call that's blocking. Well, asynchronous programming fixes that. It says, hey, while we're doing something that's blocking, I'm going to detach and allow that platform thread to be free to do something else, right? There are pros and cons to this. Improved performance and responsiveness. We get improved performance when dealing with really large databases or data sets, right? Scalability. The most important thing is we're using the resources we have much better. Cons are, though, it's all or nothing. You can't kind of mix and match asynchronous programming, right? It's all or nothing. This does separate the task from the thread. Reactive programming does have a learning curve. If you've never used it before, understanding like how it works, it's just a mind shift, right? And in certain situations, it can be harder to debug or profile. So virtual threads come in, and now we have all these lightweight threads that are not expensive to create. They are not totally always attached to a platform thread. When it needs to do something that's blocking, there's some mechanism behind the scenes where it will detach from it and just kind of go away. And because they're so light to create and so they don't use as much memory, you can basically create thousands or millions of it. It almost gives you this kind of this illusion of infinite scalability, right? So that's virtual threads. What I love about it is actually, I'll talk about that here. What I love about virtual threads in Spring applications, again, this is primarily for our MVC apps that are doing blocking operations, right? If that's all you're doing it for, you're going to see, I think, significant scalability benefits for those types of applications. What I love about this is it's ideally no code changes to the main application code base. This is really big to me. We're not asking you to go like rewrite your applications to take advantage of this. In the case of Spring Boot 3.2, it's simply a property change and you can take advantage of this. So that's what I'm really excited about when it comes to JDK 21, Project Loom, and Spring Boot 3.2. Where it doesn't make sense is maybe our applications are purely CPU bound. Maybe we're not doing anything that's blocking. Maybe we're already using reactive-based web applications. In that case, virtual threads don't make sense. You can still enable them. You're just not going to see any scalability benefits from that. The obvious question that comes up is, well, if Project Loom is here, do we still need reactive programming? And I think the answer that I've kind of been giving everyone when I'm talking about this is, if you've reached for something like asynchronous programming as simply a scalability mechanism, like we saw on a previous slide, those two options to scale, if all it was a scalability mechanism, then yes, Loom provides a different solution to that problem. There are still reasons to want to reach for reactive programming. I mentioned a couple of those JEPs earlier that are still in preview mode. One of those is structured concurrency, and that is something reactive programming handles well. Another thing you can use it for is something like Spring Web Flux as an architecture for your stream-based processing. So that's what I would say. Still a place for reactive programming, just a different reason than you might have used it before. So threads in Spring Framework 6, so anything 3.1, 3.0, there's like compatibility previews. In Spring Framework 6.1, which is Spring Boot 3.2, we have first class support through a property change. And as long as you're on JDK 21, you can take advantage of it. So I'll quickly mention these client abstractions too, which I'm a big fan of. The REST client. So we've had a way to like talk to other services, right? We can use something like the REST template in a Spring MVC app. In a reactive app, we can use the web client. We actually learned a lot from the web client, and what we did is we came back and realized that the REST template got to a point where it just kept getting overloaded methods, and hey, I need a new feature on top of that, where we kind of just got to the point where we said, okay, this is feature complete. And what we did is we learned from the web client in that Fluent style API, and we created something called the REST client. And the REST client is really similar to the REST template, but it also brings in a lot of things that the web client has. It's got a nice builder syntax. It's got a nice Fluent API. It's just intuitive and easy to use. When I create a new instance of a REST client and I say REST client dot, I'm not like bombarded with all these overloaded methods. I get a handful of methods. What is this? A GET request? There's a GET method. And it's nice because it sits on top of some underlying HTTP client libraries. There's one out of the box that's default, and actually this slide is wrong. The JDK HTTP client is not the default. The HTTP URL connection is the default, but you can change the underlying HTTP client library if you want to. And so here's an example of what I was showing you before. I create a new instance of it. I hit REST client dot, and it's very intuitive. Like I know my first step is I'm making a GET request. Then from there, I can say, go ahead and retrieve the response and turn it into a list of these things, right? And just another example of that. So I like looking at this code. When I used to deal with REST template, I was often confused on what method to use, what overloaded method to use. And I think this just simplifies a lot of things. Same for the JDBC client. We've had the JDBC template forever. This is just another level of abstraction on top of that. This is what we used to do in the JDBC template. This is fine. This still works great. But I had to write these row mappers, and that was often confusing. And then like, which method in the JDBC template do I use? Here's some SQL. This is a very simple example, but now what I can do is, actually here's some more JDBC template. So as I'm starting to write this code for like one single resource, in this case, a post, this can get pretty verbose. And I thought I had an example. Was that not an example? JDBC template. No. So I don't have an example of this on this slide. I thought I did. But the JDBC client just simplifies this code where, again, just like the REST client did, it's a lot easier. There's a Fluent API. It's intuitive. It's easy to read. And even in the case of like the row mapper that I wrote on like the previous slide here, if everything lines up correctly, like if I had a record that matches this, I could actually just pass in the record. I no longer need to write these row mappers. They're written underneath the hood for me. So if you want to be able to just write SQL and not use something like Spring Data, which if you're just getting started, maybe this is an easier approach. I find the JDBC client much more intuitive. And again, it's all around developer productivity, being easier to use on the developer side. So I think with that, I'm going to back out. Maybe I'll let Deshaun kind of jump in here and talk about some other things.
That was awesome. The thing that I always get excited, right? We're doing this all the time, but hearing Dan kind of do that overview and that replay, there's always great reminders. Like I could be a Spring certified professional. It doesn't matter. It's always nice to have those reminders. So as you were talking, I was reminded, oh, you know what? I got a project I'm working on where I could go do that. Maybe that's you. Yeah. Maybe it's just me, but thanks, Dan. Thanks for coming in and
sorry, like I said, sorry. sorry I flew through that. I wanted to get a nice overview of like the newer things in 3.1, and 3.2. And I can't wait till a few months from now we can start talking about Spring Boot 3.3.
So good. So thanks for that. Let's jump in. I'm going to remind you who I am. My name is Deshaun. I've been in this role with Dan. I'm doing this for 772 days. Before that, I worked at Redis. Before that, I was also at Pivotal, VMware, little VP of engineering time. And I worked with Elixir, who's also in the audience. I worked with him for a long time over at Garmin. You can find me online at Deshaun at these places. And just a reminder, Spring office hours, this is where you can bring your questions. So we're doing an overview and trying to get you excited about all the cool things that are in Spring. But if you have questions outside of the scope, you can always come to our show and bring your questions. We're always going to have something new. We're always going to tell you about what's on the roadmap, and we always have time for Q&A. So I like to call this kind of like a sweet and sour situation. You just got to see a bunch of really cool stuff that's all available in Spring Boot 3, Spring Framework 6, but you got to upgrade to Java 17. And I know from working with companies all over the world, I know that it's not always that easy. We're stuck, we can't upgrade, and we have too many apps, we can't upgrade. So I'm going to show you how you can get there. So it's a little bit of sour, but if you can do this, it's kind of sweet. There's some cheat codes that I want you to pay attention to. So we're going to start. Here's a repository, and this may be common for you. You're still on Java 8. You're on an older version of Spring Boot, something that might be out of support. We want you to be in support. We want you to be on the latest and greatest. We want you to have all those cool features. So I'm going to give you a cheat code. So I'm going to look at here. Here's the repository. I'm going to check out this repository. I'm going to clone it locally. So we're nothing up my sleeves. We have our repository. I'm going to jump in, and there we are. It defaults to Java 8. It hurts. But what we're going to do is we have this new tool called Spring Health Assessment, the Spring Health Assessment Report. And what it's going to do is going to help you figure out maybe which projects you want to start with, where the easy ones are to upgrade. So I'm going to show you what it looks like. We're going to go and get started. I'm going to run this. There's the commands, whether it's a Maven or a Gradle project. I'm on an Apple machine, and I'm using Maven in this project. So I'm going to copy this command. I'm going to come over here, and I'm going to run it. The cool thing is it's grabbing only the Org Spring Framework and IO Micrometer dependencies. So let's take a look at it. And you can see this is the information that's being sent to the Spring team. This is what the Spring team cares about. This is what they're trying to help you out. You're going to have a bunch of third-party projects and all of your internal projects. You don't want to send that. I get it. But you can help yourself, and you can help the Spring team by sharing this information, because even though we might be using the same dependencies, they might be in a different order, and this really helps the Spring team. So you take this, you create the Spring dependencies.txt, and then we choose that file. Let's go and choose that file, Spring, that we just made. Choose that file. I'm going to fill in my information. And the Spring Developer Advocate, and I love my job, and I work for Broadcom. And if you've got questions outside of the scope of today, you can always email me at deshaun.carter@broadcom.com. Write that down. And I live in the US. If there's time zone questions, I'm in Missouri. That's where I live. And I'm going to generate a report. It's just going to take a second. So this is for my Spring Boot 2.6 project, and this report makes me sad. This report makes me sad. There's some stuff that's not in support, and there's vulnerabilities here, and it might take a little bit to upgrade. But all of this information is generated just from this right here. So we're making some assumptions on what the rest of your stack looks like, what the rest of your app looks like. But this is just some guidance for you. So if you run this across your entire report, you might find some that are easier to upgrade. But you might have some cheat codes. So this is what the report looks like. It tells you where your support is, where it ends, where it starts. And then you also get details about the CVEs. And you can order it based on support, based on vulnerability, based on effort. So it's easy. It's a nice little report. It just takes a couple seconds to generate. But I'm here to show you the cheat codes. Some of your apps are actually going to be really easy to upgrade. So here's the repository that I'm demonstrating right now. It's the Open Rewrite Spring Boot. It's in my GitHub. And let's jump into that. Let's see how easy it can be to upgrade. So I'm going to run this demo. And it's a demo. Of course it's going to work, right? So the first thing we're going to do is we're going to clone that Hello Spring Boot 2.6 application. I'm using Java 8 because some of you are using Java 8. I'm going to clone that Hello Spring Boot 2.6 application. That's it. Now I'm going to run it. Maven. I'm doing it clean so you don't have all the stuff scrolling through, but we can see that, hey, here's our Spring Boot 2.6 application, and it started up in 1.461 seconds. It's just a Hello World app. So the only thing it has is the web and the actuator, but that's enough for us to validate it. It's up and running. Now, interesting metric. At this time, when I hit the enter button, this is how much memory that Java process was using, 370.6 megabytes. You don't have to write that down. I'll show you again at the end, but stop. Like, hey, your application, whatever its footprint is, I want you to keep those metrics. I want you to know how much value you can get out of the applications that are already running in production today. So Josh and Dan, they are familiar with all the cool features that are in Spring Boot 3. Spring Boot 3.2.2 is the latest. It came out about 13 days ago. And what I typically do, just like I did today, I typically come in behind and I say, hey, I understand you've got these apps that are already in production. Let's bring those apps back in. Let's upgrade those apps. Let's get those apps on this path forward. And it can be that easy. So what we're going to do is we're going to run this upgrade Spring Boot 3.2 recipe. That's an open rewrite recipe. This is just one of the many cheat codes that I would be happy to share with you. This is using a Maven plugin for open rewrite. And that recipe, that one recipe knows how to upgrade all the way back to like Spring Boot 1.5, which came out in like 2017. And this recipe is a set of nested recipes. It's a Java program that knows how to upgrade your code. And it's not just a search and replace. If a parameter change, a property change, or a method signature change from one parameter to two, it knows how to replace and upgrade those applications. And it goes from 2.6 to 2.7, from 2.7 to 3.0, 3.0, all the way up to the latest and greatest. So now, theoretically, I mean, it's a demo. Now I should be on Spring Boot 3.2.2. And that means I can upgrade to Java 17. I have to upgrade to Java 17, but I'm going to upgrade to Java 21 because Java 21 has been out for a long time and it's even better than Java 17. So now I've switched to my Java version, but it's the exact same application that's just been upgraded. So let's start it and let's see. Now look, same application is running 3.2.2. I didn't have to do any code. I just ran that recipe against the repository. So you can do this at scale. You can go and run this recipe. Some of your tests are going to pass, some of them aren't, but you should do it because some of your applications are going to upgrade just this easy. Starts up at 1.371 seconds. It is healthy. The same application. And look at this. We saved some memory. Our footprint is smaller. It started up faster and our footprint is smaller. And now I have access to all the cool features that Dan just overviewed. So let's stop it because we're not done. One of the other things that Dan talked about is all the cool runtime capabilities that we have. So now that I'm on Spring Boot 3, now I can take it one step further. Oh, my application isn't stopping. Oh, there we go. Now I'm going to do the native compilation. I'm going to use GraalVM. GraalVM is going to look at all of my code. It's going to analyze it. It's going to take all the code that I'm not using, and it's going to throw it away. But it's analyzing everything, and this is a compile time process. And at the end of this, and it's going to take about a minute, at the end of this, we're going to have a native image. If I'm on Windows, what that means, if I'm on Windows, I'm going to have a .exe file that I can run. But it's specific, right? Bytecode we can run on any machine that has a JVM. These native images, what we're getting from this AOT processing, it's specific to a platform and architecture. So if I can't switch from ARM64 to x86. I can't switch from Darwin to Windows. So a good idea, maybe do it in a container that's running Linux for the platform that you're doing. But also, you can deliver these native images to your developers, your team. So you can have these smaller images that start up really fast and they're ready to rock. So it's going to take a little bit of time. While that's happening, let's go and let's generate a Spring Health Assessment report because I want you to see the before and after. Actually, I'll come back to this. We're going to let this run. It takes about a minute on this machine, but we're doing the stream and it's all that. I want to remind you, ask questions. So Dan is here, ready to ask your questions. We might not be able to address all of them in this amount of time, but we're here now. It's going to be recorded. It's going to be on the video. Ask your questions. If you come to my house for dinner and you leave hungry, that's your fault. If you're here and you've got questions, you came here wanting to learn something, ask your question. If you don't, that's your fault. So don't leave hungry. Ask your questions. And if we don't address it here, you know my email, deshaun.carter@broadcom.com. We're here to help you. That's our job. So we can see it took 1 minute and 7 seconds. Now we're going to start it up. Same application that we started It went to production probably in 2018 using Java 8, and here we are. It's upgraded to 3.2.2, and look at the startup time, 0.072 seconds, and it's healthy. So it's the same application. We were able to upgrade in seconds. We were able to upgrade, and then we were able to do the AOT processing, which took a little bit of time. It's a trade-off, but it might be valuable if those things matter. If you're doing serverless workloads, or if you're just wanting to share with your developers, you want to have dozens of apps running on your laptop, this is a great way to do it because of the smaller footprint and the faster startup time. So we're up and running, and now this process is only using 83 megabytes. That's a pretty big difference. So let's stop it. Let's take a look. What did we learn? What did we just see? We saw an upgrade. We saw how easy an upgrade. I gave you a cheat code to upgrade because I want you to be on the latest and greatest. And here's what it is. We started off with Spring Boot 2.6 and Java 8. It was 370.6 megs just by doing the upgrade. Like, don't worry about the AOT image. Just by doing the upgrade, we started up faster. We use less memory, and there's some savings there. If your infrastructure cost, if your costs are a concern right now, maybe you're interested in this. So on top of all the amazing developer experience benefits that you get with Spring Boot 3.x, how about some cost savings? If you're the person that can go in and save 78% on what's running in production, if you could do that, you might get a pat on the back. Your team might even get cookies if you do this. But there's more, right? Let's go in here. Let's see. This is the output of what happened. We're going to now run this report. We're going to go get started. So this is the after. I'm going to run that same command to get my Spring dependencies. There we go. And now I'm going to go and choose that file. I'm going to go up one. Uh-oh. Here we go. The upgraded dependencies that just got created. It's this easy. I'm going to give them all my information again. In case you forgot, I'm the Spring Developer Advocate. That means I'm here at your service. We are both here at your service. We work for Broadcom. Sean.Carter@broadcom.com. I'm in the US and in Missouri. And let's generate a report. Just take a second. Whoa! So this is it. We're done here. We're about to jump into Q&A, and all I want you to know, I want you to ask yourself, which report would you rather have? Which code would you rather have running in production? This one or this one? This one, one more time, or this one. Ask yourself which one you'd rather have running in production. Ask yourself, like, hey, do I have a couple of minutes to run on those applications that I care about? Do I have a couple of minutes to try this cheat code? And it might not work. I'll be 100% honest, it might not work. But some of the applications that are running in production today are on outdated versions. They're not being supported. And you could get a bunch of benefit, a bunch of value, real money value, just by doing the upgrade. So Dan showed you all of the amazing, cool features that are there. All I want you to think about is, hey, do I have a couple minutes to be more secure? Would my CISO appreciate it if I showed him this report from today and this report in a few minutes? That's it. I'm going to stop sharing. That's all I wanted to share. I want you to know we're here to help. So I'm going to stop sharing if I can hit this button. There we go. Dan, what do you think? Are we helping people out?
That was great.
It feels good.
I hope so. Yeah. I mean, I see some questions in there, so that's good.
Well, let's take a look at the questions.
Yeah.
Let's see. What is the difference between the new JDBC client and JPA? JPA also doesn't use Roadmapper, right?
Right. So let's talk about that real quick. So every step of the way is kind of another level of abstraction, right? You can go into Java application right now, connect to a database, do your queries, do everything you need to. But that is very low level in Java. All the APIs that you're dealing with, having to deal with things like connection pools and closing a session, a lot of that is not things that I want to deal with, right? So along came the JDBC template, and that was an abstraction layer on top of that. Now we have a data source. We can just write some SQL. We had to write that row mapper. Great, but that was a new level of abstraction. Then Spring Data comes along, right? And it says, hey, we're going to give you another level of abstraction because you don't even want to write SQL. You just want to like write an entity and put some relationships on those, and we'll write all the SQL for you, right? So every step of the way has just been another level of abstraction. JDBC client is right in between there. It sits on top of the JDBC template. I would say sits on top of it. It's right above that as far as an abstraction goes, but it still allows you to like, hey, I want to write a SQL query, connect to the database, and return a response. Instead of where Spring Data comes in, that's a whole nother level where you don't even have to write some of that SQL. So it's just all a matter of what level of abstraction you're okay with. And for me, different scenarios, like if I was just having someone for the first time write a Spring Boot app, I would probably reach for the JDBC client, because if they've done some SQL in another framework before, this is going to look very familiar to them. Then when they're done, they can go, okay, here's another thing called Spring Data that will simplify your life a little bit more. So just levels of abstraction, trying to make your job a little bit easier.
Alex, thank you so much for being here. Alex has a great point that those recipes that I showed, that cheat code that I showed, I was just focused on the Spring Boot applications, the org Spring Framework libraries, but you can write your own. Open Rewrite is a framework for writing recipes that are Java programs to upgrade your internal libraries. And that's not, there's more. The third-party dependencies that you have, there are more and more people using that Open Rewrite framework. The way that we're going forward, it's 2024. The way that software is going to be managed and measured is how easy is it to upgrade? How easy is it to maintain? And the Spring team is creating these recipes, and they're building these recipes, and they're building ways for you to keep your Spring applications on the latest and greatest, to keep your Spring Boot applications on the latest and greatest, and that's what you should be doing. So think about how long it takes. Spring Boot 3.2.2 just came out a week and a half ago. And if there was a CVE, there wasn't, I don't think. If there was a CVE that had been exposed and was in there, how long does it take the latest version to get into production? Are you aware of all the vulnerabilities that you have in production? And wouldn't it be nice to just have them updated automatically? That's the way that a lot of our favorite companies are moving forward. They have this automation around their upgrades. Just think about that. Think about the application that you wrote 5 years ago. Wouldn't it be nice if you took a look at it now and it was just on the latest and greatest version of Spring, on the latest and greatest version of the JVM? Because Spring 20 or Java 21 has been out for months. It's middle-aged. Java 22 is right around the corner. We're getting a new version of Java every 6 months, a new version of Spring Boot every 6 months, a new version of Spring Framework every year, a new version of Ubuntu every 6 months. Like, you're always going to be upgrading. Wouldn't it be nice if that was just automated for you? Think about that. So, yes, another question here, like, we'll be sharing the conversion script. Yes, that's a recipe. It's an Open Rewrite recipe. My GitHub repository is available. Let me go ahead and put that repository, that demo that you can run. That demo, I'm going to put it here to everybody. You can take it and you can use it. And remember, you can contact us. Like, I don't want you to feel like you're on your own now. You're here, you're connected. We're grateful that you're here, but we're here at your service. You can call us. That's our job. Call us and we'll help. So let's keep on going. Great questions. Some of these we might not be able to go into. Like Jack, I understand there's some questions, but again, we can have these conversations offline. You don't have to get your questions here and answered here. We're happy to take some of these offline. Alex put in, the support. Yes, pay attention to the support. Springboot.io or Spring.io. Each project has its own support window, and they're different. They're not all the same. So take a look at calendar.spring.io to stay ahead of what's coming. See those releases as they're coming out so you're never caught off guard. And there's a question about handling cache and memory. I think we're going to do an episode of that coming up on Spring Office Hours. Because, there's a lot of things that it might take a little bit more time than we have left today. But again, you know how to get a hold of us. This is great.
I see another question. What are the new features in terms of authentication and authorization with the new JDBC client? Two different situations, right? Security, authorization, authentication, that is handled by Spring Security. We don't really dig into that in the JDBC client. If anything, you would secure your application with Spring Security before you got to a method where the JDBC client was used.
Yeah, happy to dig in. Well, I think that's a good spot. I'll give you a couple more minutes. Dan, thank you so much for joining today.
Thanks for having me. I love to talk about Spring. So there's only an hour. I wish we had hours to talk about it.
One of my other joys is I like helping you get over some hurdles. I want you to be able to upgrade your applications. That's why I have cheat codes, and I've got more. Reach out. But one of the other joys is I love hearing about your wins. I love hearing about what versions you're taking to production, and we're here to help. We have lots of customers that are already just days after it being released. We have customers that are running Spring Boot 3.2.2, running on Java 21, in production, containerized, secure, and ready to go. And I want you to be in that same place. It's possible.
I got another question here from Jack. Does the new REST client basically get rid of the reactive Webflux stack? So let me just answer that. Basically, if you were in a Spring MVC app before and you didn't like the REST template, and for whatever reason you were bringing in the Webflux stack dependency just to take advantage of the web client because it has this nice fluid API, it was both blocking and non-blocking, then yes, it alleviates that because you no longer need a dependency to bring in just that web client. The new REST client is built into the web dependency. So if you start a new project, you build it, you bring in web, you have the REST client available, and it can do a lot of the things that the web client does. It's not a one-to-one mapping. There are some differences between it, but I've been addressing a lot of those on my YouTube channel lately. So if you're interested in that, check that out.
Excellent work. If you'd like to stay current, if you're enjoying your time in the Spring ecosystem as much as I am, or even half as much as I am, you might be interested in something that's cool and new, the Spring Certified Professional. Like there is a certification that's been around for about 20 years, but now it's so much better. There's Spring.Academy where you can go and you can kind of level up and you can get certified. It's awesome. If you'd like to learn more about Spring, visit spring.academy. And if you're interested in being a certified professional, check out the Pro tier for just, I think it's $299 for a year subscription. And that includes a voucher for the Spring Certified Professional test. I'm doing it. Maybe you should too. Dan, this has been wonderful.
Cool. That was fun. Yeah.
Thank you so much. I think we're ready to wrap. Annie, you want to take us away?
Yeah, thank you guys so much, Dan and Deshaun. That was awesome. You guys did great today. And thanks to the audience for attending today's webcast, sponsored by Tanzu and presented by ADT Mag. Thanks, everyone. Have a great rest of your day.
Thank you.